Hello students, in this video I will explain the conceptualization of the idea of context-free grammars, that is what led to the idea of generation of the context-free grammars. I've already explained in the previous video that this module consists of two parts, that is context-free grammars and push-down automata. So under the hierarchy of computational languages, the context-free grammar is a type 2 grammar or a type 2 language, and the computational model which accepts context-free grammar, or we could tell context-free languages, is push-down automata. So before we go into the concept of context-free grammars, first let us try to understand what led to the idea of context-free grammars. And in order to support this concept, we will have to learn about the rewrite systems. When we learn about the idea of context-free grammars, I told we have to understand what is a rewrite system. So a rewrite system can be considered as a general computational model in order to accept some language or accept some form of a grammar. Okay. Now this rewrite system is also called as production system, or it can be called as a rule-based system. The term rule-based system is very apt for us to understand the concept, because a rewrite system consists of a list of rules and an algorithm for applying them. So you've got a list of rules and we consider an algorithm to apply those rules. Okay. To understand this better, just let me consider some examples. So just consider any sport. In order to play, what do? We need to follow certain rules. So rules are followed. You consider a computer game now. Even in computer games, we've got rules. Okay, and what happens along with those rules? We need to have algorithms which implement those rules. So this together, that is rules plus the algorithm which helps us to implement those rules, becomes our computational model for a game, for a computer game. Okay, so if one has to design a computational model, then one needs to know what rules have to be followed and also know how to design an algorithm to implement the rule. The same concept holds good whenever we talk about programming languages also, because in case we consider a programming language, then we need to follow certain syntactic rules of the particular programming language. This is where rewrite systems come into picture. So rewrite systems are supported by rules which are called as grammars. In reality, when we communicate with others by using a natural language, we know that we apply grammar rules, right? Now I am talking to you, I'm explaining concept to you here. I'm applying some grammatical rules in order to explain the concept in English language. So grammar helps us form correct statements of a natural language. So every natural language statement has got components, and the same holds good for any computation model which we want to construct also. Because of this, it is always easy for us, and also we could tell that it is beneficial for us to represent computational models like maybe a programming language or a game, etc., by a set of rules. So each rule which is there in a rewrite system has got a left hand side and a right hand side. We call it as LHS and RHS. So in this slide you can see examples of some rewrite system rules. That is, this part is the left hand side and this section here is the right hand side of the rule. So we tell or we read it out as S tends to A is B, AS tends to E, or we can tell ASB tends to BSA, BSA, etc. Now, whenever we have to invoke a rewrite system, let us call this rewrite system as R, and whenever we have to invoke this on some string W, okay, we follow a set of rules, or we follow a algorithm. Now, what do we do is, we take a string W and we call this as the initial string. So, the working string is set to W. We take that string W, the initial string W, and we call it as the working string. And until this rewrite system tells us to halt, we do these following steps, or we continue following these two steps. What do we do here? Since a rule has got a left hand side and a right hand side, we match the left hand side of the rule against some part of the working string. And then we replace the matched part of the working string in the right hand side of the rule that was matched. And we continue to do so till we obtain the entire string. And after that, we return the working string. And we shall see an example for this. Okay. So, if we were to consider, I'll just consider a set of rules. S tends to AS, then I can tell S tends to BS, and then S tends to epsilon. So using these rules, I want you to obtain, or I want the string AB. So how do we go? This is our string AB. We need to obtain AB. So we start with the start symbol of the rule, that is S. So in order to obtain A, we have to make use of this first rule because it starts with A. You're replacing it. Now it starts with A. So we take A as our first rule. Next, what do we do? What is the next part of the string which we have to obtain? It is B. And how do we obtain B from S? By making use of the second rule. So this S is replaced by a B. So you can tell A, B, S. So this was our second rule. BS was our second rule, which replaced the letter S. And then now, since we have obtained AB, okay, we can replace this S by the third rule, that is epsilon, and obtain the string which we require, that is AB. So a simple rewrite system can return some string S, and then we will tell that in case it can return the string S, we can tell that R derives S, the string S, from W, okay, or we also tell that there exists a derivation in R of S from W. In other words, it is just obtaining string W by using the rules in the rewrite system. And this entire concept is called as derivation. So whenever we write a rule, we can write it as S, a single arrow, ASP. But when we derive or perform derivation, then we need to have two, it's a double horizontal edged arrow, which we have to consider. Rewrite system formalism takes place by specifying a form of rules that are allowed, only allowable form of rules, along with the algorithm by which they will be applied. So, most of the rewrite systems, we consider rule as a simple pair of strings, just a pair of strings. And if the string on the left hand side matches, it is replaced by the string on the right hand side. I'll just take a rule as AXA tends to AA. What does this tell us? That we will have to squeeze out, or we could also tell replace, whatever comes between a pair of A's. So in case we have a construct like this, AXA, if we see a construct like this, we are supposed to replace it by AA. Another rule as A, B star, A, B star, A. So you can see this tends to AAA. So what are we doing? We are supposed to squeeze out, or we could also tell replace the B's between the three A's which are there. So in case there is a construct like this, we are supposed to replace it with the string AAA. So this is what happens. Most of the times it is just a simple pair of strings, and if the left hand side matches, it is replaced by the strings on the right of the right hand side. Where can rewrite systems be used? Now, rewrite systems can be used to define functions in any programming languages. We write functions in a programming language. So what are we actually doing in functions? We write rules that a function has to follow. So the particular rules operate on the input string. Whatever function you write, it operates on the input string and it produces the output string. So your rules operate on the input string and you obtain the output string. Rewrite systems are also used to define languages. So whenever we use a rewrite system to define a language, we call it as a grammar. The real-world applications of rule-based system can be the grammars of different languages. We can use rule-based systems in expert systems. We can have them in cognitive modeling. We can have them in business practice modeling. And we can also have in general models of computing. So to sum up the concept of rewrite system, a rewrite system is a simple or a general computational model which consists of rules and an algorithm to implement those rules. In the next video, we shall learn the concept of grammars, because grammars help us in defining languages which can be written through a rewrite system, or in other words, a rewrite system that is used to define a language is called as a grammar. So in the next video, we will learn about the concept of context-free grammars. Thank you.